Hello, everyone. Today we're going to cover Chapter 3, Part E, and we'll talk about the trade-off between cost and time and project crashing. What do you mean by project crashing? Project crashing means shortening or expediting some activities within a project to reduce overall project completion time. But to reduce the completion time, we need more labor and we need to invest more money. So the faster we want to finish a project, the more money we need to invest. So there is a trade-off between cost and time. So the main question we have is how to expedite the project with the least possible cost. So we'll take a couple of examples and we'll see how to do project crashing. So in the first example, we have 5 activities and we want to reduce the duration of the project by 3 weeks. And we're given the normal duration. For example, the normal duration of activity A is 6. And we're given the maximum reduction. That means we can reduce the duration of activity A by 2 weeks at most. And we're given the crash cost per week. For example, to reduce the length of activity A by 1 week, we need to spend $200 additional. What happens if you want to reduce the length of activity A by 2 weeks? Remember, this is the cost per week. So if you want to reduce the length by 2 weeks, it's going to cost us 2 times 200, 400. So using this information, what should we do to crash this project by 3 weeks? First of all, we're going to draw the activity on node network and then identify the critical path. So we're going to start from the start node. And yes, actually the activity on node network is given in this slide. Now to identify the critical path, we need to list all the possible paths from the start node to the finish node. And we have 2 paths, A, C, and B, D, E. The length of the first path is 6 plus 7, which is 13. And the length of the second one is 7 plus 6 plus 2, which is 15. Now we want to reduce the duration of the entire project by 3 weeks. That means we want, now we know that the duration of the entire project is 15. Now, if you want to reduce it by 3 weeks, that means we want to make the duration of the entire project 12 weeks. 15 minus 3, 12 weeks. Now, what should we do? Let's do this one by one. Let's say we want to reduce the duration of the project by 1 week. Then, which activity would you crash? Please pause this video, take a few minutes, and come back with your answer. Now, here we had a question. We had AC and BDE. The length of AC was 13. The length of BDE was 15. And would you crash one of the activities in the upper path or in the lower path? If you crash one of the activities in the upper path, what happens? Then the duration of this will become 12. And the duration of the second one will remain the same. And what's the duration of the entire project? The duration of the entire project is the duration of the longest path, which is 15. So the whole project is not reduced. So we don't need to crash the upper path. Right? Now what happens if we crash the lower path. If you make the lower path 14 and the upper path remains the same, the duration of the whole project is the duration of the longest path, which is now 14. So this story tells us that to reduce the duration of the entire project, we need to reduce the duration of the longest path, the critical path, right? So now we need to reduce the duration of the lower path. So in the lower path, we have 3 activities, B, D, and E. B, D, and E. And one of them needs to be crashed. Which one would you crash? B costs 250, D costs 300, and E 200. Okay, so we should crash E because this is the least expensive one. So if you crash E by 1 week, then the duration of BDE becomes 14. The duration of AC remains the same. So the duration of the whole project becomes 14. Now, let's do this one more time. We want to crash the entire project by 1 more week. Then, which one would you crash? Would you crash one of the activities in the upper path or the lower path? Still, the lower path is longer, so we need to crash one of the activities in the lower path, right? So in the lower path, we have B and D and E. Which one would you crash? We can't crash E any longer because we reached the maximum reduction. So E cannot be reduced any longer. So we need to choose between B and D. So which one would you choose? We'll choose B because it's the least expensive one. So if you crash B by 1 week, then the upper path remains the same. The lower path becomes 13. So the duration of the whole project is 13. Okay. Now, let's do this one more time. We want to crash this project by 1 more week. Which path should it crash? We have a challenge now. Now these 2 paths have the same length. There is a tie. Both of them are critical paths. So if you just crash one of the activities in the upper path and make it 12, then the duration, this becomes the longer path. So the duration of the entire project remains the same, 13. Right? Now, on the other hand, if you crash just the lower path and make it 12, then the upper path becomes the longer path. So the duration of the entire project remains the same at 13. So this story tells us that we need to crash both paths. We need to crash one of the activities from each of these paths. So we need to make the upper path 12 and the lower path 12. So from the upper path, A and C, which one would you crash? I would crash A because this is the least expensive one. And then this becomes 12. Now from the lower path, which one would you crash? Between B and D, I would crash B because B is the least expensive one. So here is the final answer. Now the project is reduced to 12. The answer is crash E and B and A and B by 1 week each. Okay, so let's summarize what we discussed so far. Use the following steps when determining the minimum cost schedule. Number 1, identify the critical activities. Number 2, select the critical activity that can still be crashed. and that has the least expensive crash cost per period. And number 3, if there is more than one critical path, consider all the critical paths and crash one activity from each of the critical paths. Now let's try one more example. Reduce the duration of the project by 4 days. And this is the network activity on node network. And from this, we can find the least sequences of activities from the start node to the finish node. We have 3 sequences, A, D, G, H, which is 17 days. The second one, B, E, G, H, which is 17 days. And the last one is C, F, H, which is 19 days. So what's the critical path? The longest path is CFH. Now we want to reduce the duration of the entire project by 4 days. So let's start from the first day. How would you crash the project by 1 day? Okay, which path would you crash? Since this is the longest path, we want to crash this path. Now we have 3 activities, C, F, H. Which one would you crash? C costs 2,700, F 3,750, H 500. So we choose the least expensive one, crash H. Then the length of CFH becomes 18. Now remember, what happens to the length of the first one? Remember, H is also in the first one. So since we crashed H, the first path becomes 16. How about the second path? H is also in the second path. So the duration of the second path becomes 16. Let's do this one more time. Let's crash the project by 1 more day. Which path should it crash? The longest path. In the longest path, we have C and F and H. Which one would you crash? We already crashed H one time, so we reached the maximum reduction. We can't reduce it any longer. So between C and F, which one would you crash? Choose the least expensive one, which is C. So if you crash C, what happens? The first one remains the same. The second one remains the same. The last one becomes 17. Now let's do this one more time. We want to crash the project by 1 more day. Which path should it crash? The longest one, this one. In the longest one, we have 3 activities. Which activity should it crash? H cannot be crashed any longer. And we choose C because C is the least expensive one. So if you crash C, the first one becomes 16, and the last one becomes. Now we crashed the project by 3 days. Now we have 1 more day to go. Now which activity, which path should it crash? Now here is a challenge. We have a tie. All these activities, all these paths have the same length. They are all critical paths. So in this case, what should we do? We need to crash all these paths. Okay? So let's start from the last one. Which activity should we crash from the last one? Between C and F and H, H cannot be reduced any longer, so we should choose C from the last one. So the last path becomes 15. Now let's go to the first and the second one. The first and the second one should be also crashed, right? So which activity should it crash from the first one and the second? We know we cannot crash H any longer. And remember, G is a common activity. So if you crash G, then both the first one and the second one are crashed, right? So this is one option, but we can also crash one from the first path and one from the second path. For example, we can crash, say, A from the first path and B from the second path, right? This is a possibility. Another possibility is crash A from the first path and E from the second. How about this? Crash D from the first and B. How about D and E, right? So these are all possible solutions. And then we're gonna compute the cost of each solution, and we'll choose the one with the least cost. So how much does it cost to crash G? To crash G, it's going to cost 14, 15, 50. How much does it cost to crash A and B? A and B, 1,300 plus 2,000, 3,300. How much does it cost to crash A and E? 1,300 plus 1,100, 2,400. How much does it cost to crash D and B? 2,000 plus 1,400, 3,400. How much does it cost to crash D and E? 1,400 plus 1,100, 2,500. Of these possibilities, which one has the least cost? 2,400. No. Actually, G is the least cost option. So if you just crash G, then the first path becomes 15, and the second path also becomes 15. Right? So that's your answer. Your final answer is crash H, and then C, and then C, and C, and G by 1 week each. Okay. So this is everything for this part. I'll see you next time.